we're going to dive into Objective 8 the same way we did Objective 7. Objective 8 is all about the cosine graph, and we're going to look at it the same way we did with the sine graph. We need our 5 key positions to understand how the graph behaves. And since those 5 key positions are all on quadrantals, we're going to look at the unit circle, but we're going to have to use the definition of cosine as x over r. We can't use adjacent over hypotenuse because we're not making triangles. We're on quadrantals. And so all we really have to do is look at the x coordinate at each of these quadrantal positions, because the r is always 1. In the unit circle, the radius is always 1. So if we're trying to graph cosine, all we need to really care about is the x, because any fraction with 1 on the denominator is just whatever that number is. So if you go back to your unit circle, you'll see of these 5 positions. When theta equals 0, the x-coordinate is 1. When theta equals pi over 2, up at 90 degrees, it's 0, and so on, and so on, and so on, as we go around the circle. So let's graph these positions. When x equals 0, the cosine of x, or when theta equals 0, the cosine of theta equals 1. So I'm just going to put 1 right up there. At 90 degrees, otherwise known as pi over 2 in radians, the cosine is 0. So I'm going to put that right there. At pi, we're at negative 1. At 3 pi over 2, we're back at 0 again. And then we're at 2 pi, so we've gone all the way around the circle, and the cosine of 360 degrees, or 2 pi, is back to 1 again. So those are my 5 key points in their key positions. Now, let me see if I can graph this halfway decently. It's a tricky graph to graph. Okay, that's not bad. And there's your parent graph of y equals cosine x. Amplitude equals 1, because there's a 1 as the leading coefficient in cosine, and there is no shifting at all. So keeping the parent graph of y equals cosine x in mind, let's look at a couple of ways we can change that. What about y equals 2 cosine x? Well, that leading coefficient simply means the amplitude is now 2. So what used to be the max and the min at 1 and negative 1 is now going to be at 2 and negative 2. So the graph is going to begin right there. It's going to go through here. Then it's going to go right there to negative 2. Then it's going to come back to 0. Then it's going to go back to 2 again. So, graphing that graph, is going to look something like that. Now, what about the next one? Y equals cosine x minus pi over 2. We're back to amplitude 1, but there is a shift, and the shift is pi over 2 to the right. So what that means is my x-axis needs to change a little bit. I'm still going to use 1 and negative 1 as my max and my min, but it doesn't start right here on the y-axis anymore. It's going to start right here. So the 1 is right there. I pass through right here. Then I hit -1 right there. And then I pass through again right there. But since I shifted 1 to the right, I actually had to add 1/2 of a pi radian to my graph. So there you go. For my next example, we're going to go back to amplitude 1, y equals cosine x plus 1. The leading coefficient in front of cosine is 1, so it's amplitude 1, which would normally make the max and the min at +1 and -1, but this plus 1 at the end of the equation indicates a shift of up 1. So my max is now going to be at 2, and my min is now going to be at 0, because everything shifted up 1 unit. So my graph is going to begin here at 2. It's going to cross right here. It's going to hit its lowest point right there. It's going to cross again right there, and it's going to come back to the beginning at the end of 2 pi. So let's try to graph it. And there we go. For my last example, I'm going to have y equals -1/2 cosine x. Now, the amplitude is 1/2. There is no shift left or right, but there is that negative sign, which reflect across the x-axis. So my max and my min are only going to be at +1/2 and -1/2, and I'm going to reflect the graph across the x-axis. So instead of starting at +1/2, it's actually going to start at -1/2. And then it's going to pass through 0 right there. It's going to reach its peak at +1/2. It's going to pass through 0 again right there. And then it's going to get to its lowest point right there. So I will make kind of a half a parabola, then an entire parabola, and then a half a parabola. And there's your graph.